Imagine this, a silent intruder from the depths of the galaxy, hurtling through the void at unimaginable speeds, carrying secrets from a star system we may never see. It's not a shooting star from our own backyard. It's an ancient wanderer, older than our solar system itself, whispering tales of distant worlds. What if this cosmic messenger holds the clues to life beyond Earth, or the birth of planets unlike our own? If that sends a chill down your spine and ignites your curiosity, hit that subscribe button right now, turn on notifications, and join me on this interstellar adventure. You won't believe what's coming next. Let's rewind to that fateful night in the Chilean Andes, where the stars align not just in the sky, but in the data streams of cutting-edge telescopes. On July 1st, 2025, astronomers at the NASA-funded Asteroid Terrestrial Impact Last Alert System, better known as ATLAS in Rio Hurtado, Chile, caught a faint, enigmatic blip on their screens. This wasn't just another routine scan for Earth-threatening asteroids. ATLAS combs the heavens every 2 nights, hunting for anything that could pose a risk. But this object, initially tagged as a potential near-Earth asteroid, quickly revealed its true nature. It was dim, hovering at an apparent magnitude around 18, faint enough to challenge even the mightiest observatories. But its motion was all wrong for something born in our solar system. The excitement built like a gathering storm. Follow-up observations flooded in from global networks, with over 30 observatories contributing more than 120 precise measurements by the next day. The International Astronomical Union wasted no time. On July 2nd, 2025, they officially confirmed it as an interstellar interloper, the third ever detected. Dubbed 3I/ATLAS, or formerly C/2025N1 ATLAS, this comet became an instant sensation. Digging into archival data pushed the story back even further. Pre-discovery images from multiple ATLAS telescopes and Caltech's Zwicky Transient Facility at Palomar Observatory in California showed glimpses as early as June 14th, 2025. At that point, it was lurking about 4.4 astronomical units, AU, from the Sun, roughly 410 million miles away, nestled within Jupiter's orbital realm. Can you picture the scene? Astronomers huddled around monitors, coffee cups forgotten, as emails zipped across continents. This visitor was barreling in from the constellation Sagittarius, a direction hinting at origins deep in the Milky Way's bustling core. To put this in perspective, our first interstellar guest, 1I/ʻOumuamua, was spotted in October 2017 by Hawaii's Pan-STARRS telescope, a rocky, elongated enigma about 400 meters long, tumbling silently without a coma or tail. Then in August 2019, amateur astronomer Gennady Borisov in Crimea discovered 2I/Borisov, a gaseous comet with a nucleus around 1 kilometer wide, complete with a classic tail. Now 3I/ATLAS bridges those worlds, icy and active like Borisov, yet with peculiarities that echo ʻOumuamua's alien vibe. This breakthrough didn't emerge from thin air. It's the fruit of decades of technological leaps in sky surveying. Systems like ATLAS, with their relentless all-sky scans, have revolutionized our ability to snag these elusive travelers. Before 2017, we'd never pinned down an interstellar object. The cosmos felt infinitely vast and lonely. In under a decade, 3 have crashed our party. Is it sheer luck, sharper tools, or a sign that the galaxy is teeming with such nomads? Hold that thought. We'll explore it soon. For now, here's the kicker. At discovery, 3I/ATLAS was clocked at 137,000 miles per hour, 221,000 kilometers per hour, or 61 kilometers per hour. Second, blazing faster than any local object at that distance, an unmistakable badge of its extraterrestrial origins. Now let's peel back the layers of this mysterious Voyager. What's it made of, and why does it matter? From the outset, observations screamed comet. By early July 2025, astronomers detected a coma, a hazy shroud of gas and dust enveloping the nucleus, and subtle hints of a tail forming. This activity solidified its comet status, distinguishing it from the asteroid like Oumuamua. Diving deeper, size estimates have evolved with fresh data. NASA's Hubble Space Telescope snapped images on July 21st, 2025, when the comet was 277 million miles from Earth, revealing a teardrop-shaped dust cocoon and pegging the nucleus's upper diameter at 3.5 miles, 5.6 kilometers, though it could be as compact as 1,444 feet, 440 meters across. More recent photos from the Vera C. Rubin Observatory, captured on June 21, 2025, and analyzed in a July 17th preprint, suggest a likely diameter of about 7 miles, 11.2 kilometers, making 3I/ATLAS the largest interstellar object yet observed, dwarfing Oumuamua's 0.2-mile width and Borisov's 0.6-mile nucleus. Its coma, meanwhile, stretches up to 15 miles, 24 kilometers across in early views, though it's expanding steadily. The real drama unfolds in its chemical makeup, unveiled by powerhouse telescopes. On August 6, 2025, the James Webb Space Telescope, JWST, trained its near-infrared spectrograph, NIR-SPEC, on the comet, dissecting its spectral fingerprints. NASA's SPHERE-X mission followed suit from August 7 to 15, 2025, confirming an abundance of carbon dioxide, CO2, in the coma, alongside water ice in the nucleus and traces of carbon monoxide, CO. Strikingly, the CO2 to water, H2O, ratio clocks in at around 8:1, one of the highest ever recorded in a comet. This is hard fact, backed by spectral analysis and published research notes. The coma lacks detectable CO, suggesting the comet was well-baked and boiled in its past, perhaps stripped by cosmic radiation during its long journey. These elements mirror those in our solar system's comets, like Oort cloud relics, but the CO2 dominance stands out. Comets are frozen snapshots of their birthplaces, locking away primordial materials. High CO2 implies formation in a colder, more distant zone of its original protoplanetary disk, where such ices could condense freely, or in a system exposed to intense stellar winds or radiation. Gemini South Telescope images from August 27, 2025, capture the growing tail, a scientific milestone that highlights a reddish tint in the coma, possibly from organic-rich dust mixed with icy grains. Here's where facts meet fascination. 3I/ATLAS began outgassing far from the Sun, beyond 5 AU, outside Jupiter's orbit, where solar warmth typically can't trigger such volatility. Most comets activate closer in, around 3 astronomical units or less. Yet images show the coma ballooning by late July, with steady brightening and no reported outbursts or breaks. This early activity is observed reality, but its cause, that's where speculation creeps in, which we'll address later. For now, these details paint 3I/ATLAS as a potent time capsule, rich in volatiles that could reveal how chemistry brews in alien realms. If composition tells us what this comet is, its trajectory unveils the how and where from. And trust me, it's a heart-pounding ride. 3I/ATLAS traces a hyperbolic orbit with an eccentricity well over 1, meaning it's unbound by the Sun's gravity. This isn't a looping path like our planets. It's a near-straight shot, like a galactic arrow slicing through our system. Approaching from Sagittarius, potentially the Milky Way's thick disk, a realm of ancient stars, it was about 410 million miles from the Sun at discovery. Its perihelion, the solar close-up, arrives around October 30th, 2025, at 1.4 astronomical units, 130 million miles, just inside Mars's orbit. There, its speed will surge, building on the 61 kilometers per second at detection. Post-perihelion, it swings by Earth at a safe 1.6 to 1.8 astronomical units, 150 to 170 million miles, in December 2025, then exits toward the outer system by mid-2026, forever escaping our grasp. No major planetary close calls noted, but it will pass near Mars' distance and could offer NASA's Juno spacecraft at Jupiter a fleeting glance if alignments cooperate. Its motion is retrograde, opposite our planet's direction, and inclined just 5 degrees to the ecliptic, adding an eerie counterflow feel. Tracking shows pure gravitational obedience so far, with no anomalies. But that swift, flat trajectory, it evokes images of a slingshot ejection from a distant star, perhaps a binary system or stellar flyby after eons adrift. All right, let's bridge facts to the bigger picture, staying grounded while exploring the what-ifs. Factually, 3I/ATLAS offers a priceless peek into extrasolar chemistry. Its CO2 heavy makeup suggests diverse planet-building recipes elsewhere. Maybe carbon-laden worlds with greenhouse atmospheres or icy moons primed for volatiles. JWST and SphereX data refine our exoplanet models, showing how interstellar radiation weathers comets over billions of years. The detection rate, 3 and 8 years, implies these wanderers are plentiful. Estimates from ʻOumuamua suggest thousands traverse our system undetected at any moment. Upcoming scopes like Vera C. Rubin could uncover dozens more, bolstering planetary defense. Atlas spotted this early, but a larger, faster threat could demand upgrades like NASA's NEO Surveyor. Now veering into theory, some posit these objects seed life via panspermia, ferrying organic molecules galaxy-wide. If 3I/ATLAS hails from the Milky Way's ancient thick disk, as models suggest, it could carry pre-solar system relics, reshaping our understanding of galactic evolution. But these are hypotheses not proven, fueled by data but awaiting more evidence. This is where passions ignite in conference rooms and preprints. Origin tops the list. Facts confirm interstellar roots, but from where? Statistical models point to the Milky Way's thick disk, older stars implying an age over 7 billion years, predating our 4.5 billion-year-old solar system by billions. A two-thirds chance it's the oldest comet observed, per defies.org reports. The artificiality hype? Early light emission far out sparked alien tech whispers, reminiscent of Harvard's Avi Loeb theorizing ʻOumuamua as a solar sail. A controversial preprint echoed that for 3I/ATLAS, citing non-gravitational pushes. But experts like Northeastern's Jacqueline McCleary counter, it's a natural comet without gassing, especially CO2, explaining the activity. No unexplained accelerations. Solar, wind, and gravity suffice. Composition sparks contention too. Is the 8-to-1 CO2 ratio birthright or from eons of erosion? JWST leans toward inherent, but some argue it's akin to rare solar comets. As perihelion nears, more data will settle scores, perhaps revealing hidden ices or organics. Beyond labs, 3I/ATLAS stirs our souls in a tech-driven era of AI and space races. It's a galactic postcard, affirming we're part of a connected cosmos. Sci-fi lovers see echoes of Arthur C. Clarke's Rendezvous with Rama, a mysterious visitor probing humanity, or Andy Weir's Project Hail Mary, where interstellar finds spark alliances. Public buzz mixes awe and jitters. Social media erupts with memes and theories. But NASA webinars and image releases educate, quelling fears. It fosters global unity, from Chile's ATLAS to Europe's telescopes, a human triumph amid worldly woes. In uncertain times, it reignites wonder, urging us to gaze upward and ponder our place. As 3I/ATLAS races toward its solar spotlight, the universe feels alive, brimming with enigmas and bonds. This isn't mere ice and dust. It's a billion-year-old envoy bearing galactic whispers. We've probed it with Hubble's gaze, JWST's spectra, and SphereX's scans. Now October's revelations await. Natural marvel or timely harbinger, it shouts that space is dialogue, not void. If this cosmic tale left you starstruck, smash that like button, subscribe for more universe unraveling adventures, and ring the bell. The next discovery might rewrite reality. Share with a sky-gazing buddy and stay tuned. The stars are just warming up. What do you think? Could 3I/ATLAS be carrying clues to alien life? Or is it just another quirky cosmic drifter? Drop your thoughts in the comments below.